Welcome to our journey through the universe. Have you ever looked up at the night sky and wondered, what are those shining lights? Today, we're going to explore stars, those amazing objects that have fascinated people for ages. We'll look at what stars are, how they form, the different types that exist, their life cycles, and why they are important in our universe. We'll also discover how humans have studied these bright lights over time and what they tell us about space. So, grab your telescope, and let's get started. Stars are huge objects in space made mostly of hydrogen and helium, the two lightest and most common elements. Hydrogen makes up about 74% of a star's mass, while helium accounts for roughly 24%. The rest includes small amounts of heavier elements like carbon, oxygen, and iron, which are crucial for forming planets and life. Stars create energy through a process called nuclear fusion, happening in their cores. In this process, hydrogen atoms combine to form helium, releasing a lot of energy as light and heat. This energy is what makes stars shine in the night sky. How bright a star appears, known as its brightness, depends on its size, temperature, and distance from Earth. For example, bigger and hotter stars look much brighter than smaller and cooler ones. The color of a star also indicates its temperature. Blue stars are the hottest, followed by white, yellow, orange, and red stars, which are the coolest. This variety gives us a beautiful display of stars at night. Stars begin their lives in nebulae, which are large, cold clouds of gas and dust scattered throughout galaxies. These clouds can act as nurseries for stars. Inside these clouds, some areas become denser, often triggered by events like nearby explosions or collisions with other clouds. When a section of gas and dust becomes dense enough, gravity pulls it together, leading to a collapse. As the material collapses, it forms a protostar, a dense center that collects more material from its surroundings. The protostar keeps gathering gas and dust, and as it gets smaller, its temperature rises. Once it gets hot enough, about 10 million degrees Celsius, nuclear fusion starts, marking the birth of a new star. This whole process can take millions of years, and the new star may be surrounded by a disk of material that can turn into planets and moons. The birth of stars shows us how dynamic our universe is, revealing how new stars create the building blocks for galaxies, stars, and ultimately, life itself. Stars go through a fascinating life cycle, which can be described in a few main stages. Main sequence. This is the longest stage in a star's life, lasting billions of years. During this time, stars fuse hydrogen into helium, generating energy that keeps them stable. Our sun has been in this phase for about 4.6 billion years, and will continue for another 5 billion years. Red giant. When a star runs out of hydrogen, it becomes a red giant. The core shrinks, and the outer layers expand and cool, giving the star a reddish color. During this phase, helium fusion begins, creating heavier elements like carbon and oxygen. The outer layers might eventually drift away, forming a colorful cloud called a planetary nebula. Supernova. For massive stars, the end of their life is a spectacular explosion known as a supernova. This happens when the core can no longer support nuclear fusion, causing a rapid collapse followed by an explosive outward force. Supernova are among the most powerful events in the universe, scattering elements like carbon and iron into space, which helps create new stars and planets. Final stages. After a supernova, the remaining core can become different types of objects. If it's about 1.423 times the mass of our sun, it may turn into a neutron star, an incredibly dense object that spins quickly and emits radiation. If it's even heavier, it can collapse into a black hole, a point in space with such strong gravity that nothing can escape, even light. The edge of a black hole is called the event horizon, which marks the point of no return. Each stage of a star's life shows us the exciting and changing processes that shape our universe, helping us understand the origins of elements and the nature of cosmic evolution. Stars come in many types based on their characteristics and life stages. Main sequence stars. These stars, like our sun, are in the longest part of their lives, fusing hydrogen into helium. They make up about 90% of all stars in the universe. Their sizes can vary from smaller than the sun to much larger, and their colors range from blue to red, depending on their temperature. Red giants. After using up their hydrogen, stars become red giants. They can grow to several times the size of the sun and cool down, appearing reddish. Supergiants. These stars are even bigger than red giants and are very bright. They produce heavier elements through fusion, but have shorter lifetimes due to their size and rapid fuel consumption. White dwarfs. These are the leftover cores of small to medium stars that have shed their outer layers. White dwarfs are hot but dim and will slowly cool down over billions of years. Neutron stars and black holes, the remnants of massive stars after a supernova, become neutron stars, which are extremely dense. Black holes, on the other hand, have gravity so strong that nothing can escape them. The concept of the event horizon around a black hole adds an intriguing aspect to our understanding of these remnants. Understanding these types of stars helps astronomers classify them and predict how they will behave over time, giving us more insight into the universe. Stars play important roles in the universe illumination. They provide light that helps shape nighttime ecosystems and influences the behaviors of animals, guiding creatures that are active at night. Creation of elements through nuclear fusion. Stars create essential elements like carbon, oxygen, and iron. When they explode, they scatter these elements across space, allowing new stars and planets to form. In fact, all the heavier elements in our bodies originated in the cores of ancient stars. Guiding navigation throughout history, humans have used stars for navigation and keeping track of time. Ancient sailors used the positions of stars to find their way, while constellations helped mark seasons and agricultural cycles. For example, the North Star has been a reliable guide for navigation in the Northern Hemisphere for centuries. Cultural and scientific significance. Stars have inspired countless myths, stories, and pieces of art. They have fueled scientific inquiry, leading to discoveries in astronomy, physics, and our understanding of the universe. Studying stars allows us to learn about the formation of galaxies, the evolution of the universe, and even the possibility of life beyond Earth. Stars are not just distant points of light, they are vital to our existence, influencing both the physical universe and our cultural heritage. Stargazing has inspired wonder and curiosity in people for thousands of years. Ancient civilizations built observatories, like Stonehenge and the pyramids of Giza, aligning them with celestial bodies. They created calendars based on star movements and seasons, reflecting their deep connection to the night sky. Today, with advanced telescopes and space observatories like the Hubble Space Telescope and the upcoming James Webb Space Telescope, we can observe stars in incredible detail. These tools provide us with stunning images and information that improve our understanding of how stars live and die and give us insights into the formation of galaxies and the overall structure of the universe. The observations made by these telescopes help scientists study things like where stars are born, remnants of supernova, and distant galaxies, revealing a universe that is always changing and full of mysteries waiting to be discovered. Engaging in the scientific study of stars not only broadens our knowledge, but also deepens our appreciation for the beauty and complexity of the cosmos. Stars impact life on Earth in many ways. Our Sun, a medium-sized main sequence star, is essential for life. It provides the energy needed for photosynthesis, which supports all the planet's ecosystems. Moreover, the light from stars helps astronomers learn about the history of the universe. The light we see from stars today left them millions of years ago, meaning we are essentially looking back in time. This cosmic time travel helps scientists understand the evolution of galaxies and the universe itself. In summary, stars are fascinating celestial objects that play key roles in the universe. From their birth in nebulae to their explosive deaths, they are not just points of light, they are vital components of the cosmos that shape our understanding of life, space, and time. So the next time you look up at the night sky, remember you're looking at the life stories of billions of stars. Thank you for joining us on this cosmic journey.